My other cat came by. This is Toda. Although at the moment she's not too happy, so she's gonna go. Ouch. I got a little bit of a scratch. Okay. What we want to do now is fix our unique random number generator to actually generate unique random numbers. Before it was generating random numbers, but sometimes they repeated. So how are we going to do this? Let's go back to the scratch pad and think about how we would do this ourselves manually. So let's think how we would generate a unique set of random numbers. Well, the first one is always going to be unique, so we might just generate a random number, like 3. Now, when it's time to generate the second random number, maybe what we do is we ask the random number generator to generate a random number, but instead of just putting it in, first what we do is we kind of get a temporary random number, and we check to see if it is in fact unique. And the way we do that is by checking it, in this case the number 2, against all of the previous random numbers. So, is 2 different than 3? Well, yes, it is. Great. So let's go ahead and put it in. Let's do the next one. So we will go ahead and generate a temporary random number. Say it's 4. And now we check 4 against the other random numbers in the list. Is 4 different than 3? Yes. Is 4 different than 2? Yes. Great. We can go ahead and write it down. Let's try again. In this case, maybe the random number generator generates the number 3. And so what we'll say is 3 unique. Is it different than 3? Whoops, no it's not. Okay, so we've got a problem. We have to generate a new random number. So we go back here, cross that out, and make a new one. Maybe this time it generates the number 5. And we try again. Is 5 different than 3? Yes. Is 5 different than 2? Yes. Is 5 different than 4? Yes. It's good. So let's go ahead and put in the number 5. And we're good to go. I think we have the basics of a unique random number generator. Now that we have the basic idea of how we're going to generate our random numbers, let's go ahead and code it. So we'll go up here and make a new method, define unique rands, right, as opposed to a non-unique random numbers. Similarly, we'll take the number of random numbers we want to generate and the maximum value of those random numbers. Again, actually it will look sort of similar. Why don't we go ahead and copy this, and we'll just change what we need to. Copy the old one, right? So we've got a empty list. We're going to loop for the number of random numbers we need to generate. But now, instead of calling the random number generator directly to generate any random number, what we want to do is make a new function which is going to generate a unique random number. We haven't written that yet, but let's just call it, and then we'll define it afterwards. We can say generate unique random number, and we need to pass in the current list of random numbers for that function to be able to determine if the new one is unique. So what we'll do is we'll give it the current list of random numbers, tell it what the maximum value is, and tell it to go do it. If that works, then we go ahead, take the random number, append it to our list, and when we're done, we return our list. And that is our function, even though we've skipped an important part. This, again, as we've talked about earlier, is an important way to write code, because what we've done is we've written this in a clear and simple way that is understandable, even though we haven't written all of it. We've used a separation of concerns. We have a high-level generator that relies on some other part of the system that's going to do something else. We can't test this yet because we can't even run it because we haven't implemented that other function. So let's go ahead and write that function. We're going to define generate unique rand, and it's going to take a list of random numbers and the maximum value. And what we'll do is first generate a potential random number, same way we did before, random.rand int between 1 and max. So now we'll iterate through the previous random numbers, which is just all of the numbers in the current rands list. So we can iterate. We'll put it in a variable called prev, because these are the previous one, in rands. And what we want to do is say, is the new thing rand different than the old one. Well, if it is not different, that's a problem. So what do? Well, remember what we had figured out when we sketched it out. If we generate a new random number that is the same as one of the previous ones, that's a problem, so we have to come up with a new number. So what we'll do is just generate a new random number in this case. Okay, if it was different, then we're fine. We just use the one we already generated. Okay, we let the loop finish, and we return rand. That looks like it might work. Now, how do we know if it really works? Well, remember our testing harness? At the bottom, we have a call to our test. Before, we're using non-unique rands. Let's change it to use the new method that we defined, unique rands. Remember, unique rands calls this thing we just wrote, gen unique rand. Oh, we're left missing a colon here. And now we can try this out. So, what do you think? Is it going to work? Let's find out. We run this, and it says not unique. 4. Here's the list that it generated. 1, 4, 3, 4. Not good, right? It didn't work. We have a bug. What could be causing the bug? I want you to stop the video, take a few minutes, go through gen unique rand, and see by looking at this code and by drawing out a box, a list with some boxes, just in your own head, try generating some random numbers and see if you can figure out why this doesn't work. Okay, did you figure it out? Well, the issue is that with the random number we generate is the same as one of the previous one, we generate a new random number, but who's to say whether the new one we generated is actually still different than the other ones, right? That might not be good enough. We might have to keep on generating random numbers over and over again until we keep on finding one that's different. So what do? Well, instead of just saying if, what we really want to do is we want to say while the new random number is the same as one of the previous ones, try generating a new one. And if that one isn't good, try it again. And if that one isn't unique, try it again. This is looping, but it's a different kind of looping than the for loop. The for loop looped a fixed number of times that was defined in advance based on the list that you were iterating over. Instead, what we want to do is a different kind of looping where we keep on looping as long as some condition is true. When that in this case, the condition is the new random number is the same as a previous one. When we finally get to the point where our new random number is different than all of the other ones, it's not the same, our condition is false, and we want our loop to stop. There is a different keyword in Python that lets you do this kind of looping, which is determined, the number of loops it actually loops depends on a current condition. It's not defined up in advance. And we can, the condition, the name of the Python word is while. And so it actually reads a lot like English, and it's very simple. It just takes a single Boolean condition, just like the if statement, right? All I did was replace if with while. And you can say, while some condition is true, execute a body of code. And so what this will do is this will execute this body of code over and over and over again as long as rand is equal to prev. But as soon as it's different, then rand will not be equal to prev. This condition will evaluate to false, and the while loop won't loop anymore, and it will continue on. So, what do you think? Will this solve our problem? Again, I'd like you to turn off the video, pause the video for a moment, and take a piece of paper and try and write out some examples and see if you can figure out whether or not this is going to work. Well, let's try it out. Let's run. And the answer is no. In fact, we can run it several times. Actually, by luck, we actually got a successful list that was all unique. But we try it again, and it's not. In other words, you might be lucky, but it's not guaranteed. We've got a bug. And in this case, well, we can see the same kind of thing happened. We got an 8, 7, 2, 1, and then another 8. So what's going on? The problem is we are properly looping to generate new random numbers. But the thing is, we're looping in the wrong place because we're only generating new random numbers if the new random number is the same as the last one on the current one on the list that was the same. Remember, we have a whole long list of random numbers, and if at the time we're evaluating this one and this one is duplicated, well, we might repeat and generate a new one for here, but we're not checking this against all of the other ones. So we might generate a new random number that's different than this, but it might not be different than one of the previous ones we already checked. So what we really need to do is go back to the way we had it before and move the while loop outside of the for loop, because what we want to do is we want to regenerate the entire for loop until we have, as long as there is a non-unique random number until we get a unique one. So what we're going to do instead of this is say, if our new random number is the same as the previous, we are going to set a flag, a new variable that I'll call repeat, and say true. That is, we want to repeat. We are not satisfied with the result. And then what we'll do is at the very beginning, we're going to say while repeat. We'll indent all of this. Got a few more things to do. The first time through, repeat isn't defined, so we're going to define the repeat variable to be true up front, so that the very first time through, the while loop will execute its body. And then what we want to do is inside the while loop say repeat equals false. Because now what we're going to do, what this does, is this says, okay, we're going to repeat once. Now we're going to execute this code, and let's hope that we have a good list with no repeated values. So we set repeat to false, and we try. We generate a random number. We check against our previous ones in the list, and if we find a problem, then we set repeat to true. But if we didn't find any problems, then repeat is false. We fall out of the while loop down to the end, and we return rand. Notice PyCharm has underline rand, and if we mouse over, it'll give us a little warning. Local variable rand might be referenced before assignment. That is, there's a chance, at least conceptually, that rand was returned without ever being assigned to. We know it's being assigned to here, but since it's in a while loop, the editor doesn't know that rand was assigned. So to be absolutely clear, we're going to set rand to be none. Let's see if this works. Let's click on the run, and it says true. And in fact, if we go look at these numbers, we can see it does in fact have the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, we don't know that wasn't just lucky, so let's run it again. And in fact, every time we run this, it says true. Our testing harness is saying we are consistently getting a unique set of random numbers. By the way, I think didn't mention, I had changed the test to have 10 random numbers with a maximum value of 10. Now, I've just run this a whole bunch of times and it's true every time. Is it possible that we just have had good luck and that there still is a bug? And the answer is yes. It is very hard when you're doing something like this with generating random numbers that you can be positive that every possible sequence of random numbers that the system generates will result in a correct result. So we don't have proof that this works. But I'm pretty confident because it's working a lot, And I looked through the logic, and it makes, I'm highly confident that it works. So there you have it, a tested and functioning function that generates a unique list of random numbers, and at the same time we've introduced the new while statement.